The CIA Triad is a fundamental concept in cybersecurity that represents the three core principles of information security: confidentiality, integrity, and availability. These principles serve as a framework for evaluating and implementing security measures to protect data and information systems. Here's an overview of each component of the CIA Triad. Confidentiality. Confidentiality ensures that data is kept private and only accessible to authorized users or entities. The goal is to prevent unauthorized access or disclosure of sensitive information. Measures to achieve confidentiality include encryption, access controls, authentication, and data classification. Examples of confidential data include personal information, trade secrets, and financial records. Integrity. Integrity focuses on the accuracy and reliability of data. It ensures that data remains unchanged and uncorrupted during storage, transmission, or processing. Maintaining data integrity is vital to prevent unauthorized tampering, modification, or corruption of data. Techniques to ensure integrity include checksums, digital signatures, and version control systems. For instance, if a file is altered without authorization, it may compromise data integrity. Availability. Availability ensures that data and information systems are accessible when needed by authorized users. This involves safeguarding against disruptions, downtime, or denial of service attacks. Redundancy, backup systems, disaster recovery plans, and fault tolerance are some strategies to ensure the availability of data and services. Downtime or service unavailability can disrupt business operations or cause significant inconveniences to users. The CIA Triad is a foundational framework that helps security professionals and organizations design, implement, and assess security measures. While these three principles are at the core of cybersecurity, other concepts and principles, such as non-repudiation, authenticity, and accountability, are often considered alongside the CIA Triad to provide a more comprehensive approach to information security. Confidentiality. Confidentiality is one of the core principles of the CIA Triad in cybersecurity, and it refers to the protection of data from unauthorized access, disclosure, or exposure. The goal of confidentiality is to ensure that sensitive or private information remains private and is only accessible to individuals or entities who have the appropriate authorization to access it. Here are some key aspects of confidentiality in cybersecurity. Data encryption. One of the most common methods to achieve confidentiality is through data encryption. This process involves converting the original data into an unreadable format, ciphertext, using cryptographic algorithms. Only individuals with the appropriate encryption keys can decrypt and access the original data. Access controls. Access controls are mechanisms that restrict access to data and systems based on user permissions. User authentication and authorization are integral parts of access control. Authentication verifies the identity of a user, while authorization determines what actions or data the user is allowed to access. Data classification. Data is not all of equal importance. Data classification is the process of categorizing data based on its sensitivity or importance. This helps in applying appropriate security measures to protect more critical information more rigorously. Security policies. Organizations often establish security policies that define how sensitive information should be handled. These policies may include guidelines for data access, sharing, and storage to maintain confidentiality. Physical security. Confidential information is not limited to digital data. It can also include physical documents, devices, or storage media. Physical security measures, such as locked cabinets, secure facilities, and restricted access areas, play a crucial role in maintaining confidentiality. Data loss prevention, DLP solutions are used to monitor and prevent the unauthorized transfer or exposure of sensitive data. They can detect and block the transmission of confidential information outside of the organization's network. Security awareness and training. Educating employees and users about the importance of confidentiality and best practices for safeguarding sensitive data is essential. Human error is a common cause of data breaches, so awareness and training can mitigate risks. Confidentiality is critical in various sectors, including healthcare, protecting patient records, finance, securing financial data, and government, protecting classified information. It is also essential for safeguarding personal information and intellectual property. Maintaining confidentiality helps protect an organization's reputation, prevent legal and financial consequences, and build trust with customers, partners, and stakeholders. Integrity. Integrity, in the context of cybersecurity and the CIA Triad, refers to the assurance that data remains accurate, consistent, and unaltered during its entire lifecycle. Maintaining data integrity is vital to ensure that information is not tampered with, corrupted, or modified by unauthorized or malicious actors. Here are some key aspects of data integrity in cybersecurity. Data validation and verification. To maintain data integrity, organizations employ validation and verification mechanisms to ensure the accuracy and consistency of data. This involves using techniques like checksums, hashing algorithms, and digital signatures to verify that data has not been tampered with during transmission or storage. Access controls. Controlling access to data is not only important for confidentiality but also for integrity. Limiting who can modify data is a crucial aspect of ensuring its accuracy. Unauthorized changes can compromise the integrity of data. Version control. Version control systems are used to track changes made to data and documents. They allow organizations to maintain a historical record of changes and revert to earlier versions if data integrity is compromised. Change management. Change management processes help organizations implement changes to data, systems, or configurations in a controlled and secure manner. Proper change management practices can prevent unintended changes that could impact data integrity. Error detection and correction. Error detection and correction techniques, such as parity bits and redundancy in storage, can help identify and fix errors in data, ensuring that the data remains accurate. Auditing and logging. Maintaining detailed audit logs of who accessed, modified, or attempted to modify data is essential for data integrity. These logs help in detecting and investigating unauthorized or malicious changes. Backup and recovery. Regular data backups and disaster recovery plans are essential to recover data in its original, unaltered form in case of data corruption or loss due to various factors, including cyber attacks or hardware failures. Data integrity is crucial in various sectors, including finance, for financial records, healthcare, for patient medical records, and critical infrastructure, for industrial control systems. It also plays a role in ensuring the reliability of digital transactions, digital content, and information systems. Failing to maintain data integrity can lead to erroneous decision-making, loss of trust, and potentially severe consequences for businesses and individuals. In summary, data integrity focuses on preserving the accuracy and consistency of data, ensuring that it remains trustworthy and reliable, and protecting it from unauthorized modifications or corruption. Availability. Availability, in the context of the CIA Triad in cybersecurity, refers to the principle that data and information systems should be accessible and operational when needed by authorized users. Ensuring availability involves protecting against disruptions, downtime, and denial of service attacks, which could otherwise render data and services inaccessible. Here are some key aspects of availability in cybersecurity. Redundancy. Redundancy involves duplicating critical components or systems to ensure continued operation in the event of a failure. Redundant hardware, network connections, and data centers are examples of measures taken to enhance availability. Fault tolerance. Fault-tolerant systems are designed to continue operating even when some components fail. This involves building resilience into the architecture, such as using load balancing and failover mechanisms. High availability (HA) solutions. HA solutions are specifically designed to minimize downtime. They use technologies like clustering and load balancing to ensure that if one server or component fails, another takes over seamlessly. Backup and disaster recovery. Regular backups of data and systems are crucial for availability. In the event of data loss or system failure, a well-defined disaster recovery plan ensures that services can be quickly restored. Monitoring and alerting. Continuous monitoring of systems and networks is essential to detect issues that could impact availability. Real-time alerts and notifications help IT teams respond quickly to any potential problems. Distributed denial of service (DDoS) protection. DDoS attacks can overwhelm systems and render them unavailable. DDoS protection measures are used to mitigate the impact of such attacks and maintain service availability. Data center design. The physical design of data centers, including power and cooling systems, physical security, and geographic location, plays a role in ensuring uninterrupted service availability. Cloud Services and Infrastructure as a Service, IaaS. Many organizations leverage cloud services and IaaS providers to enhance availability. These providers offer scalable, redundant, and geographically distributed infrastructure to maintain high levels of availability. Service Level Agreements, SLAs between service providers and customers often include availability guarantees. Service providers commit to a specified level of availability, and customers can hold them accountable if these commitments are not met. Availability is critical for various applications, especially in sectors like e-commerce, finance, healthcare, and critical infrastructure. Downtime can result in financial losses, compromised customer trust, and, in some cases, even harm to public safety. Balancing availability with the other two components of the CIA Triad, confidentiality and integrity, is essential. Implementing rigorous availability measures should not compromise security and data protection. A well-rounded cybersecurity strategy should address all three principles to effectively manage risk and protect information assets.